Journey into Nature. This is the American Museum of Natural History, Hayden Planetarium. Into the firmament above me, man has placed products of his own genius, lacing the skies with rockets, adding to the flickering stars his own small lights. It is the new lights in the sky that we will examine as we journey into nature. Journey into Nature, a special series of programs produced by WNBC in cooperation with the American Museum of Natural History, an institution dedicated to the search for knowledge in the fields of natural science. Within the many exhibit halls of the museum, you will find accurate representations of what man has learned of himself and the world that surrounds him. Journey into Nature will visit many of the exhibits, talk with the staff members and research scientists of the museum in order to capture in sound the wealth of knowledge on display, to bring you the excitement of learning, to explore the wonders of the world. Here now is your host, Kenneth Banghart.
Good afternoon. Journey into Nature today will venture beyond the pull of the Earth's gravity and will investigate the vehicles that have carried instruments beyond the upper atmosphere of Earth. Our subject, space and rockets. For 1,000,000 years, man has looked and wondered. And from the wonder, from a desire to know how and why, has come the knowledge on which civilization is built. Through the ages, man has peered at the sky and has developed technology that allows him to see more clearly what exists in the universe that surrounds him. Now, his technology has carried him within a short step of actually setting foot on other stars. The rocket is his vehicle, outer space his highway. And there is so much about both that is unknown. On our journey into nature today, we'll examine what is known of rockets and space. Our guide today is Dr. Franklin Branly, a member of the staff of the American Museum Hayden Planetarium. I'll be stepping aside to turn my microphone over to 6 young interviewers who will question Dr. Branly on rockets, space, and space travel. Dr. Branly, let's start this journey with you and a brief statement about what progress we have made in our reach for space. Dr. Branly?
In the past 3 years, we've made significant progress in the exploration of outer space. We've sent balloons up to altitudes of about 100,000 feet. And with these balloons, we've learned a great deal about the upper atmosphere. And we've also taken many photographs of the sun in particular that gives us a lot of details about the structure of the sun. And then, of course, with artificial satellites, we've gone out to much greater distances, several thousands of miles. And these satellites have contained instruments that have revealed, the Van Allen belts. And we've also found out with Pioneer 5 a new electrical field about 40,000 miles from the Earth, which is different from the Van Allen belts. We've been taking photographs of the Earth, as you know, with TIROS, the weather satellite. And we have Pioneer 5 again, which is going all the way around the sun, will probably stay in orbit for 100,000 years, and that's a long, long time. So we are well on the way toward the exploration of outer space. We have plans for the future, which include Project Mercury, which is man in space. This means that a man will actually go in orbit around the Earth 3 times, and then land safely, we hope, in the Atlantic Ocean. And also we have plans for putting a 36-inch telescope that's a very big telescope, into outer space. This will be a satellite telescope which will photograph the sun and the stars and the planets, and perhaps we'll learn more about astronomy with that one telescope than man has learned ever since 1609, when the telescope was first invented. So things look very good in the exploration of outer space.
Gerald Corfield, how much air pressure can the outside of a rocket ship hold?
Well, nobody knows actually, Joel, but it can hold a tremendous amount. You mean how much vacuum, really, don't you?
Yes.
It can hold a tremendous amount because, you see, the rocket is curved, and a curved surface can withstand terrific pressure. So we have no worry about a rocket actually collapsing or exploding because of pressure differences. I can't give you a specific figure, but that's no particular problem.
Alfred Decker, how much gas is there in a rocket?
By gas, do you mean fuel?
Yes.
Well, you have to be specific about the rocket. The fuel percentage, the percentage of fuel in a rocket is about 80% of the total weight. So it depends, you see. If you have a 20-ton rocket, then you'd have about 16 tons of fuel.
Frank Barone, how long does it take to make a rocket?
Well, for a while there, we were making rockets one at a time. That is, we'd start a rocket, and then we would complete it, and then we'd start another rocket and complete it. But now, many of our rockets are being made on a production line, the same way that automobiles are manufactured. And so I would say, in answer to your question, just to be a little more specific, that the large rockets, the ICBMs, probably in the order of 8 to 10 weeks.
How far can the newest rocket go?
Well, the record ICBM rocket is the Atlas, and that covered 9,000 miles. That is, from point to point, from a point on the surface of the Earth to another point on the surface of the Earth, 9,000 miles.
Thank you. Betty G. McGrogan, about how long will it take the next rocket to reach Mars?
You don't mean the next rocket to reach Mars, you mean the first rocket to reach Mars. Well, let's see now. We reached the moon. Well, the Russians reached the moon in about 35 hours. And the moon is 250,000 miles away, and Mars is 35 million miles away at its closest. So it'd be, about 1,500 hours, 1,000 to 1,500 hours, something. Like that.
Alfred Decker, how long will it be before we reach the planet Mars?
Well, we're not especially excited or concerned about reaching Mars. We would like to put into orbit around Mars an instrumented satellite. This would go around Mars, would have instruments aboard which would measure the temperature, radiation, gravitational fields, magnetic fields, and so on. And we can anticipate that this kind of adventure may take place within the next 5 years. As far as man reaching Mars, this is another question. It's quite different.
What is the Frank Brown, what is the material of a spacesuit?
You mean that the men wear?
Yes.
Well, usually they're made of a rubberized, plasticized fabric, and invariably they will have a shiny surface so that they will reflect heat. You've probably seen the suits that firefighters wear that go into oil wells. Well, they look something like that, except that they have also a pressure suit inside. And a pressure suit is a device to keep the body from exploding. In case there should be a sudden drop in pressure, the pressure suit tightens up and holds you in, keeps you from spreading out all over the place. That could be very messy.
Rita Trini, when was Pioneer 5 first sent up?
Pioneer 5 was launched on March 11 of this year, March 11, 1960, and beginning of June it was about 11 million miles away, and of course it's always pulling farther away from Earth.
How much pressure can the spacesuits hold in the space?
Well, they can easily withstand that is a G pressure of about 25 Gs. Do you know what a G is? Well, 1 G is the force of gravity. So if you're subject to twice the pull of gravity here on the Earth, this would be 2 Gs. That means you would weigh twice as much as you now weigh. So if you were how much do you weigh?
83 pounds.
83 pounds. So if you were subjected to 10 Gs of pressure, you'd weigh 830 pounds. Be kind of hard to walk around.
Is there, Frank Brown, is there life on Mars?
Well, we have no evidence of life existing anywhere in the universe, for that matter, except on the planet Earth. There is no real, sound, foolproof evidence. There are many people who believe that there is some kind of life on Mars, plant life perhaps, but actually we cannot definitely prove its existence.
This is Kenneth Banghart, and I'd like to interrupt the questioning just for a moment to bring an important message about the American Museum Hayden Planetarium.
In the year 1054 AD, astronomers in China recorded the appearance of a new star. For several months it blazed so brightly that it could be seen in the daytime. Then it disappeared. In its place in the sky today is the glowing, swirling cloud of gas we call the Crab Nebula. At the American Museum Hayden Planetarium this summer, you will see a dramatic recreation of that exploding star. Its strange remnant is one of the 7 celestial objects of extraordinary beauty and interest in the exciting sky presentation, The 7 Wonders of the Universe. Like all presentations at the planetarium, this summer's sky show dramatizes new discoveries at the very frontiers of astronomical research. The origin of the Earth, the birth and death of stars, the architecture of our galaxy, the magnitude of the island universes. These revelations and concepts of modern astronomy are interpreted in fascinating visual form in the planetarium's great man-made sky. You can visit the planetarium any day of the week. There are sky shows several times each day, and every evening except Monday. And if you or members of your family are interested in learning more about astronomy, why not find out now about the evening and Saturday courses starting in September at the planetarium? These courses, some for adults, others for young people, deal with astronomy, space science, navigation, and meteorology. For a catalog of courses, write or phone the American Museum Hayden Planetarium, 81st Street and Central Park West, New York 24, New York. And now back to Kenneth Banghart and Part 2 of Journey into Nature.
We are talking to Dr. Franklin Branly, a member of the staff of the American Museum Hayden Planetarium. Our subject, space and rockets. And this afternoon, I've turned my chair over to 6 youngsters who have the questions prepared for Dr. Branly. So we'll start with you, young man. What's your name and your question?
Alfred Decker.
How big is the compartment in which the person would be placed when he's in the rocket?
Well, this varies. I can talk a little better about Project Mercury. Do you know about that? This is the plan to put a man into space. And actually, a man does not get into a rocket. He gets into a capsule that is inside the rocket. And the capsule for Project Mercury is 9 feet tall and 6 feet across, so that the man inside has to be sort of semi-reclining in a sponge rubber sofa. He's sort of on his back with his legs up in the air somewhat.
Neely Donor, how many oxygen tanks do men need to breathe on other planets?
Well, I don't know about how many, but if a person were on another planet, a person from Earth were on the moon or any of the planets of our solar system, he would have to have a steady supply of oxygen. And there may be ways of reprocessing waste materials from a man so that the oxygen could be reclaimed, or there may be ways of processing rock material on planetary surfaces and getting oxygen out. So it isn't a case of how many, it's a case of a continuous supply. He'd need it all the time. He'd have to breathe supplied oxygen. It wouldn't be there readily available to him.
Thank you. Gerald Cliffield, when do you think our rockets will reach the moon?
You mean just a rocket to reach the moon, not with a man inside of it?
No.
Just to land on the moon, I would say this year, 1960.
Thank you.
Rita Tranny, do you think we'll ever reach the moon?
Oh, sure. You mean a man? A man, sure. Within, I would say certainly within 5 years. Would you like to go?
Betty G. McGrogan, how do you know what kind of air and the temperature of other planets?
Well, this is a tricky business. Actually, the astronomer uses an instrument called a spectroscope or a spectrograph, and this analyzes the light coming from a planet, studies the light, and different gases produce different light. And by the kind of light produced, we get an indication of the kind of gases there are in the atmosphere. And we learn the temperature of a planet by actually sending the light from the planet through a special instrument called a bolometer, and this bolometer measures the temperature of the planet. So we know this quite well, and we also find out about temperature of a planet by radio astronomy, by learning the kind of radio noise the planet produces. This indicates temperature.
Rita Tranny, how do you go about finding out about new planets?
About new planets, discovering planets, you mean?
Mm-hmm.
Well, there are many ways of doing it. William Herschel, who discovered the first planet, did it just by hit and miss. He looked at every little object that he saw in the sky, and finally he found the planet Uranus. And then Adams and Leverrier discovered Neptune, and they found Neptune by figuring out on paper, mathematically, just where another planet should be, and they looked into the sky and they found it. And then we discovered Pluto, or Clyde Tombaugh discovered Pluto, by taking photographs of the sky, and by matching one photograph against another, he finally found an object that turned out to be Pluto. So it's done in many different ways.
Thank you.
Betty G. McGrogan, how do you find out how far planets are from each other?
Well, we can actually measure distances in space with great precision. We do it by measuring angles. You know, if you hold your finger in front of your eye, and then you close one eye, and then open that eye and close the other, your finger sort of shifts back and forth. Well, this is called parallax. And we do somewhat the same thing with stars and planets, and we can measure the distances by knowing those angles of shift. We can do this with great accuracy.
What is the force, Gerald Cliffield, what is the force of gravity change on each planet?
Well, because gravity is related to mass. The more massive an object is, the greater its gravitational attraction. You see, we have a gravity, we would call our gravity, let's say, 1. Give it a value of 1. Well, the moon, the mass of the moon is much less than the mass of the Earth, only about 1/80th of what our mass is. So its gravitational attraction is only 1/6 as great. And then the sun is much more massive, so its gravitational force is about 80 times our gravitational force. Depends upon the mass, or if you want to call it that, the weight of the object. The greater the weight, the greater the gravity.
Thank you.
Frank Brown, is it true that the name of Uranus is Uranus or Uranus?
Uranus.
Uranus?
It's a correct pronunciation is Uranus.
Joe Clifford, why are these planets named so funny, like Pluto?
Well, they're usually named after gods, Greek or Roman gods. And if you look up a little mythology, you can find these names in these mythological stories. And the names of the planets really are quite interesting because many of them had other names at other times, and they have gradually come to be accepted as we know them today.
Alfred Decker, how big is the Milky Way?
Do you mean the Milky Way galaxy?
Yes.
Well, the Milky Way galaxy, for you people who don't understand the question, is the part of the universe in which we are located. And it's a tremendous division, tremendous segment of the universe. And from one side of the Milky Way galaxy to the other is 100,000 light years. 100,000 light years. And a light year is the distance light travels in 1 year, or 6 million miles. So in miles, our galaxy is 100,000 by times 6 million. That's in miles. And our galaxy contains 150 billion stars.
Thank you.
Frank Barone, what is the speed of a satellite in orbit?
Well, this will vary depending upon its distance from the Earth. But most of the satellites, well, let's say many of the satellites that have been put into orbit have been at 300-mile altitudes. And in order to stay in an orbit at that altitude, they have to go approximately 18,000 miles per hour. This is the average speed. When they're a little closer to us, they go faster. When they're farther away, they go slower. But 18,000 miles per hour for a 300-mile orbit.
Thank you, Dr. Branley, and thanks to our 6 young interviewers who have carried us another step forward in our journey into nature.
Journey into Nature has been a special program produced by WNBC in cooperation with the American Museum of Natural History. It is based on the thousands of exhibits that are yours to see in the museum. Join us again next week as we explore the museum, seeking out the natural wonders of our world. Journey into Nature is written and directed by Alan Landsberg, produced by Steve White. Your host is Kenneth Banghart. Fred Collins speaking. This program was pre-recorded.
WNBC and WNBC-FM, New York.